Hello everybody and welcome to the fourth video of the TypeScript Engine tutorial series. In the last video, we still left off pretty much with a blank black screen like you see here. But what we did was we set up some shaders, we got those to compile and to link, and WebGL to use them, but we're not actually passing any vertex data to it. And so what we need to do is we need to actually give it some data to display on the screen. And so that's actually what I'm going to do in this video. So the first thing that I want to do is I'm going to go ahead and create some more temporary stuff in the engine, and we're actually going to wind up moving a little bit of this stuff around sometime soon. But for right now, what I want to do is go ahead and create a WebGL buffer. So I'm going to create a private buffer, GL buffer. And what a buffer is it's a container for data to be pushed to the graphics card to be used in the shader, specifically the vertex shader. So when we were talking about this attribute here that we're looking for as far as position goes, that positional data, this attribute, is stored in a buffer that we're actually going to use. So we're actually going to populate this buffer with that data. And so in order to do that, I'm actually going to create another private method. And I'm going to call it create buffer for now. And again, this is going to be moved around a little bit. We need to clean this up a little bit, but just for the sake of getting something on the screen, I'm going to do it here for right now. So the first thing I need to do is say this.buffer equals gl.createBuffer. So if you haven't guessed it, you're going to see this pattern a lot with things. You're going to see this gl.createX. And so all that does is it creates a buffer for us to then use to load up data with. So the next thing we actually need to do is to create some data to pass to it. So what I'm going to do is create a new variable called vertices. And it's actually going to be an array of numbers. And what these numbers are going to represent is positional data, vertices, positional vertexes in space. So it's going to be XYZ points in 3D space represented here. So what I'm going to do is I'm actually going to say 0, 0, 0. And so this is X, Y, Z. In fact, let me just put a comment here for clarity. X, Y, Z. And then for our second point, I'm going to say 0, 0.5, 0. For the third point, I'm going to put 0.5, 0.5, 0. So you'll notice that the z-axis is always on 0, and that is because we actually don't want it to go deep into the screen. And I'm actually going to explain the axes in a little bit, but for now, just understand that the z-axis is always on 0 for a 2D context. So what this is actually going to represent, if you haven't figured it out already, is a triangle. So if we're looking at a graph, for example, it's going to be, let me say, so if we're looking at a graph, and we have, let's say, a grid here, excuse my terrible art here, what this is actually going to represent is in OpenGL, 0, 0 is actually at the bottom of the screen. So your screen is actually here. And 0, 0 is down here. So this first point, 0, 0, and of course 0 on the z-axis, is going to be here. And so the next thing that's going to happen is the next point is 0, 0.5. So this 0.5 right now represents halfway on the screen. So that's going to be about here. Because, oops, I'm sorry. It's actually not going to be there. It's actually going to be here. Wrong axis. Sorry about that. It's on the y-axis. So that's going to be the second point, and then the third point is going to be 0.5, 0.5, which is going to be here. So we're going to get a triangle that looks something like this. Only not as crappy. So, great. Now we have our vertex data. Now we need to actually load it into the buffer. So what we do is we say gl.bindBuffer, and it's asking for a target. And so the target is gl.arrayBuffer, and the buffer is this .buffer. And what you're saying is, GL, we want to bind this buffer to an array buffer. And this array buffer is basically saying it's an array of values. That's all it means. And so the next thing that we actually have to do is we actually have to tell WebGL how we're going to pass the data, what format the data is in, and how that should be used. And to do that might be a little bit tricky to understand, but let's go ahead and jump into that now. So what we're going to say is gl.bufferData. And so this is saying, GL, I want to pass you some data. And the target, again, is gl.arrayBuffer. And then what this is going to do is it's going to use the buffer that was bound previously. So here we're saying GL, we want to use this buffer. And now we're saying GL, the buffer that we're currently using, we want to fill with some data. Okay, and so the next parameter is, for some reason, strangely named size. And I'm not really sure why it takes just a number here. That's normally not what we ever want. But you'll see that there's all these other types that it can actually take. And so the one that we're actually interested in is a float32 array. And a float32 array is a type that was developed, I believe it was added specifically for WebGL. I could be wrong about that. But it is an object that takes in a bunch of numbers and converts them to 32-bit floating point numbers under the hood. And that's actually what WebGL uses and OpenGL subsequently uses to represent this data. Now, you could also pass integers, unsigned integers of different bits, different sizes rather. But for now, we're going to stick with float32 array. So we want to say new float32 array, and this expects a length, which we don't want. We say array or array buffer. That's actually the one that we're going to want. So we're going to actually pass in vertices to that. And the next thing that we want to do is define usage. And this is basically telling GL how we want it to be used. How do we want this buffer to be used? And we're actually going to say GL static draw. And so that means that this data is not going to be changing very often, and that we just want GL to draw it to the screen. And that's it. And so at this point, we can either leave the buffer bound or we can unbind it. Typically, it's good practice to unbind it when we're done loading data into it. So to do that, you just say GL bind buffer, GL.arrayBuffer, and then pass undefined as the buffer. And it'll be more obvious later on why we want to do that, but I want to get that set up now so that it doesn't sort of bite us later. Okay, so at this point we can call this.createBuffer, and in our loop, this is actually what's going to be drawing our our stuff. So after we clear the screen, we actually want to draw the buffer. So what we want to say is gl.bindBuffer, bind buffer, gl.arrayBuffer, array buffer, this.buffer. Okay. So similar to what we did down here, we're just saying, hey, GL, we want to use this buffer, and we want to target it as an array buffer. And after that, we want to say gl.draw arrays. And this is basically going to say we want to draw an array of data that we've passed to you in the buffer. And so it needs a couple of things. The first thing that it needs is a mode. And the mode can be a few different things. We can say that we want to draw lines, we can say that we want to draw triangles, a triangle strip. There's a bunch of different things that we can do. 90% of the time, or 95% of the time, you're going to want this to be GL triangles. If you note, you can actually see a couple of the other types here. We have triangle fan and triangle strip. We're not going to be using those. I almost never use those. GL triangles, 95% of the time is what we want. The only one I ever use commonly is GL lines, but I'm not going to go into that for now. So we've got GL triangles, and the next thing that we do is first. So what it's looking for the first is basically where in the array do we want to start. And in this case, it's going to be 0. Basically, we're saying start at 0 position, at the 0th position in the array. And the count is going to be how many elements do we want. Now, if you recall, the position, which is what we're calling one vertex, is a vector 3, meaning it has an x, y, and a z for each one of these positions. So in our vertices here, we have an x, y, z, x, y, z, x, y, z. And so what we're looking for is how many of these do we have? In this case, it's 3. So we put a 3 there. Okay? And that should be everything we need to do. Let's go ahead and compile this and run it and see what we get. Oh dear. Okay. That's cannot clear color of null. I'm not really sure what happened there, to be honest. Let me force reload this. You know what, let me try running this again, because it looks like something strange happened in the browser there, and I'm not really sure why it's losing context like that. Give me a moment off screen to figure this out. So I actually see what I did wrong. I forgot to tell WebGL what the location of this attribute is. So in shaders, you can actually have more than one attribute. You can have a second one here that maybe contains normals or something like that. And so each one of these actually has a location based off of the location that you have reserved for it in the shader. So this would be location 0, this would be location 1, and so forth. And so I actually need to tell WebGL some additional information about that attribute in order to have it be bound correctly when we're actually doing this. So what I want to go ahead and do is, before I load the buffer data, I need to call gl.vertexAttrib pointer. And the index on that is going to be, in this case, 0. And I'll come back to that in a little bit. The size on that, I believe, is going to be the number of bytes per element. So a floating point number is 4 bytes. And the type is going to be a GL float. Normalized, we don't want to normalize any data that's going in there, so we're actually going to say false. The stride is going to be 0, which is basically saying how many elements do we want to skip between each one of these elements that we're dealing with in the array. And for this case, we want to say 0. We don't want to skip anything. And offset is basically saying how far into the array of information do you want to start. And in our case, again, that's going to be 0. And the next thing we need to do is gl.enable vertex attribute array, which is basically enabling this for use. And again, it's going to be 0. Okay, so the next thing we're going to need to do is, since we're rebinding this up here, and if unbound it here, let's see, what I actually need to do is we want to disable the attribute array. And I believe we're actually going to need a copy of these up here before we call draw arrays. So that should work. Okay. GL draw attempt to access out of range vertices in attribute 0. Okay, so that means something in here, and one of these values is messed up. I see what I did wrong. I was actually thinking the wrong thing. This should be a 3. This isn't the size in bytes, it's actually the number of elements within each vertex. Sorry about that. Alright, so now we have our triangle as expected. Although, I'm not quite sure. There we go. Okay, so I need to do a resizing there. Let me... Okay, so I just want to point something out. Let me rerun this real quick. So notice how this looks really blurry, and the size of this isn't right and whatnot when we first load up here. But when we resize, it sort of fixes itself. So let's go ahead and fix that issue so we don't have to resize it every time we open. So in order to do that in the engine, right before we enter the loop, after we've done everything else we need to do, let's call this .resize. And that'll run our resize code once, just to make sure that everything is sized up properly before we actually start rendering. And now this happens automatically. So one thing that I've noticed is despite us actually creating this as 0, 0, 0, for some reason this is offset. Okay. And the reason that is offset is because we didn't actually tell GL where on the screen to render its output. So remember how I said that we have this sort of box that we render here. We haven't told WebGL yet how big that box should be or where on the screen it should actually start drawing. So we need to do that. So in our resize code, we need to add one more line. We need to say GL this.viewport. And this takes an x and y, which is the position. We want that to be 0, 0. And then the width is going to be this.canvas.width. And the height is going to be this.canvas.height. So that those things always match up. So let's go ahead and build this and run. And that still seems wrong. Give me one moment to figure this out. Okay, so I figured it out. So what it actually was I had forgotten about something called normalized device coordinates. And what this is the way that OpenGL actually represents the screen. So this representation here isn't 100% accurate. So let me just erase this. Yeah, that's good enough. So the actual screen takes up this right here. And you know what? This is a pretty terrible drawing. Let me just delete it and start over. There we go. Okay, so if you remember in math, you have your 4 quadrants of a graph like this, and your 0, 0 is always right here in the center. And WebGL is no different. So WebGL renders this entire area. And it uses something called Normalized Device Coordinates, or NDC. And NDC is described as the overall coordinates that the device recognizes to put things on the screen. So typically what most programs use is they'll give you this quadrant up here to use, because this is all positive values, right? Positive on the x, positive on the y. But OpenGL actually gives you the negative values as well. So what we have over here is we have -1 over here and 1 over here. And then we have -1 down here and 1 here. So we have our 0, 0 here, which is our first point in our triangle. And then we have our 0, 0.5 here. And then we have our 0.5, 0.5 here, which explains the triangle that we got. And so if I wanted to use just this quadrant, I'd have to set this up a little bit differently to accept that. But I'm not going to bother with doing that because the way that we're actually going to display this is going to change anyways. But I just wanted to sort of re-explain that and make that a little bit more clear as to why that didn't show up 100% the way that I was originally expecting it, is because I forgot about normalized device coordinates and the fact that it actually is from -1 to 1, not 0 to 1. So I just wanted to bring that up. So with that, this is actually complete. It's working as expected. It works properly when it's resized. You'll notice that it stretches a little bit when it's resized in the extreme on one axis or the other, and that is what we're going to eventually fix. So with that, I'm going to go ahead and end this video here. So thank you guys so much for watching. If you haven't already, consider subscribing, and I will see you guys on the next video.